Dear students, in previous class we were discussing about the Legendre symbol. We know that what is Legendre symbol? If P be an order prime and n is incongruent 0 mod P, then n by P equals 1 if n is a quadratic residue mod P and equals minus 1 if n is quadratic non-residue mod P. Here, in this class now let us discuss about another symbol which is known as Jacobi's symbol. Jacobi's symbol. What is Jacobi's symbol? This Jacobi's symbol is again that is defined also in terms of Legendre symbol. For Legendre symbol, we choose P is an order prime and n is incongruence 0 mod P. But in Jacobi's symbol, we choose this P in such a way that P is a positive odd integer. P is positive number, means it is positive odd integer. Means P equals 3, 5, 7, it's a positive odd integer 3, 5, 7, 9, etc. So P is a positive odd integer. Then with the prime factorization, we know that every composite number has a prime factorization, and if P be a positive odd integer with the prime factorization, P equals product I ranges from 1 to r Pi to the power ai, where each Pi is a prime. Here what is Pi? Where Pi is a prime. Pi is an order prime. Since P is an order positive integer, and if P has a prime factorization, P equals product I ranges from 1 to r Pi to the power ai, where each Pi is an order prime. Then the Jacobi symbol n by P is defined as, again this is the Jacobi symbol, P is a capital letter, capital P. Here n by P is defined as n by P equals product I ranges from 1 to r n by Pi all to the power a, where this n by Pi is a Legendre symbol. This is Jacobi symbol. Jacobi symbol is defined as it is for all the positive odd integer, need not be a prime, all the positive odd integer, where that odd integer has a prime factorization like this, product I ranges from 1 to r Pi to the power a, where each Pi is an order prime. Then the Jacobi symbol n by P is defined as it is product I ranges from 1 to r n by Pi to the power a. What is n by Pi? We know that this n by Pi is Legendre symbol. And which are the possible values of this n by Pi? It is 1 or minus 1 or 0. These are the possible values of n by Pi. Here n by P equals 0 when P is n congruent 0 mod P. P divides n congruent 0 mod P. So, the possible values of Legendre symbol is 1, minus 1, 0. Therefore, the possible values of Jacobi symbol is also 1 and minus 1, 0. When that is depends upon this AIs. Agree. Okay. So, if the congruence means here the Jacobi symbol again, the Jacobi symbol n by P equals 0 when here again P greater, so the GCD of P and n is greater than 1 means P is a multiple of En. Agree. Like this Legendre symbol. Now, consider the quadratic congruence. X square congruence to n mod P, where Pi is an order prime. If the quadratic congruence x square congruence to n mod Pi has a solution, that is n is a quadratic residue mod Pi, then we know that this n by Pi equals 1. Why? Because if x square congruence to n mod Pi has a solution means n is a quadratic residue mod P. N is a quadratic residue mod P means n by Pi is 1 by Legendre symbol. When n by Pi equals 1, then what about the product? That means product I ranges from 1 to r n by Pi all to the power a is again 1 itself. So that means product I ranges from 1 to r n by Pi all to the power a. N by Pi all to the power a. N by Pi is 1. So it is again 1. Why? Because that is nothing but the product. Hence, that means this n by P is also. So, when x square contributes to n mod pi for all I has a solution, means n is quadratic residue mod pi, then n by p equals 1, where p has a prime factorization product ranges from 1 to 1, pi to the power a. So, when n by pi equals 1, surely n by p equals 1. But a reverse inclusion need not be true. Means when n by p equals 1, we need not be say that n by pi equals 1, we say that n by p equals 1. But when n by p equals 1, it is need not be true that n by pi equals 1 for all I. Why? Because it depends upon the power. Agree? Okay. Now we are going to the properties of this Jacobi symbol. We know that Legendre symbol is a completely multiplicative. That is mn by p equals m by p into n by p for all m and n. That is by the completeness property of Legendre symbol. Here the first property, suppose p and q are positive odd, p and q are odd positive integers. Odd positive integers. Then the first property states that m by p into n by p, m by p into n by p equals mn by p. M by p into n by p equals mn by p. How to prove this one? So its proof is, what is p? We know that p and q are positive odd integers. Then suppose p and q has the prime factorization. Suppose p equals product I ranges from 1 to r, pi power ai, and or pi power some, as p equals product I ranges from 1 to r, pi power ai. Then what about mn by p? Therefore mn by p equals product I ranges from 1 to r, product I ranges from 1 to r, it is mn by pi all to the power ai by because of Legendre symbol. Sorry, Jacobi symbol. If p has a prime factorization like this, then by the definition of Jacobi symbol, mn by p is when p has this prime factorization, then n by p is product I ranges from 1 to r n by pi to the power a. That is by the definition of Jacobi symbol. So in the light of that definition, if p has a prime factorization like that, then mn by p equals product I ranges from 1 to r mn by pi to the power a. So that is nothing but which is equals product I ranges from 1 to r, it is m by pi all to the power a into product I ranges from 1 to 1 n by pi all to the power a. Why? Because we know that mn by pi, we know that mn by pi by Legendre symbol, we know that mn by pi equals m by pi into n by p. Why? Because the Legendre symbol is completely multiplicative. That is because of the complete multiplicative property of the Legendre symbol. There is mn by pi is nothing but m by pi into n by p. So what is mn by pi all to the power ai? So it is mn by pi all to the power ai. Its product is nothing but product mn by pi all to the power of a is nothing but product I ranges from 1 to r m by pi all to the power a into n by pi all to the power a. What about this one? This is m by p, that is by Jacobi symbol, into whatever next product, it is n by p. So finally mn by p is nothing but m by p into n by p. So the proof is heavily depends upon the completeness property of Legendre symbol. mn by pi is nothing but m by pi into n by pi. Okay, so what is mn by pi all to the power ai? It is m by pi all to the power ai into n by pi all to the power ai and so on. Agreed. So finally mn by p is m by p into n by p. So this is our first property. Agreed. Now we are going to the second property of Jacobi symbol. The second property is when p and q are odd primes, then n by p into n by q, n by p into n by q equals n by pq. N by p into n by q equals n by pq. So here, suppose is again p and q are order primes. So first we suppose that p has a prime factorization. P equals product I ranges from 1 to r, pi to the power k. And q has a prime factorization. Q equals product I ranges from 1 to r, qj power, or j ranges from 1 to r, qj power bj. Okay, j ranges from 1 to s, or maybe 1, not 1 to r, 1 to s. It has the p and q has these types of prime factorization. So what is pq here? pq means it is p1 power a1 etc. pr power an into q1 power b1 etc. qs power bs. So this is pq. So what is n by pq? N by pq equals, by, since pq has this prime factorization, so it is n by pq is n by p1 to the power a1 into n by p2 to the power a2 into etc. into n by pr to the power or to the power a. Why? Because of, by the definition of Legendre's into again n by q1 to the power b1 etc. into n by bj or n by bs to the power bs, n by qs to the power bs. Agreed? So what is this one actually? This is product I ranges from 1 to r, n by pi to the power ai into product j ranges from 1 to s, it is n by qj all to the power bj. Enough. So this is nothing but product I ranges from 1 to r n by pi to the power pi, where product I ranges from 1 to r pi to the power a is nothing but the prime factorization of p. So by the Jacobi symbol, it is n by p into n by q. So we have n by p into n by q is nothing but n by pq. So this is the proof of or this is the second property of Jacobi symbol. For any p and q are order primes, then n by pq is n by p into n by q.